Hello again. In the previous video I explained what happens when an observer moves towards the center of a spherical wave of light. A similar explanation can be applied when the observer moves in the opposite direction, that is, away from the center of the wave. As before, in this video I show that the observed wave is different from the real wave, and this makes the illusion that the speed of light is the same to all observers regardless of their own speeds relative to the source of light.
Again, we have a spherical wave of light and an observer. We choose 2 points A and B on the wavefront. The velocity vectors are normal to the surface of the wave, as are the radii of the sphere. Now the observer moves backwards at the speed of v. This is the equivalent situation, and these are the resultant velocity vectors which correspond to an illusory wavefront. We see that the apparent curvature of this wavefront is greater than the real curvature, and the apparent center is nearer than the real center. The similarity between these two triangles shows that the apparent center moves at the speed of v towards the observer. So we started from an observer moving away from the center of the wave, and now we see that the apparent center is moving towards the observer at the same speed. As in the previous video, for illustrative purposes I have shown the angle between the two rays very large. In practice, the two rays reaching the eye of the observer are almost parallel, and the 2 points A and B almost coincide. Therefore, the apparent radius O'A equals OA minus OO', or CT minus VT. In other words, the radius of the observed wave increases at the speed of c minus v. Now imagine a spherical wave of light that its radius is increasing at the speed of c minus v, and its center is moving towards an observer at the speed of v. Then the wavefront will be approaching the observer at the speed of c minus v plus v, which is equal to c. Remember that in the case explained in the previous video, the observer was moving in the opposite direction, and we had the speed of c plus v minus v, which was again equal to c.
Our observations are subject to many kinds of visual illusions. A familiar illusion happens when a stick is partly immersed in water. The stick appears to be bent, but we know that it is not really bent. The bending happens in our visual perception, not in the outside world. Similarly, the speed of light appears to be constant to all observers, although it is not really constant. When we are trying to establish a theory based on our observations, we must be cautious not to confuse our visual mistakes with the external reality. I have more explanations in the next videos.